Where do you see 8 from the equation in the graph? The y-intercept. All right, so it gave you this equation. What form is this equation in? Good. Y equals mx plus b, or slope-intercept form is the proper name. So in slope-intercept form, the 8 is having to represent the y-intercept since it's the number not attached to the x. And you can see it on the graph on the y-axis. So yeah, that's my y-intercept. Table 4, where do you see the -2 from the equation in the graph? That it's going down 2 for every 1. What do we call that? Slope. So the slope and the fact that it's going down 2 in the y for every 1 interval on the x. Okay. Now table 5, what is the x-intercept of a graph? 4, good. Table 6, how does the 4 relate to the equation? So the x-intercept is 4. Do we see a 4 in the given equation? No. Does anyone know where the 4 would necessarily go? For the x, when what happens? Do you guys remember what I would always remind you of in the last unit? Like your y-intercept is whenever x is at the y-axis. What's true about all the x's? No, these are negative, so that's not it. What's true about all the x's at the y-axis? The y-intercept is whenever the x is 0, okay? So if we're talking about the x-intercept is 4, what's the value of the y? Come on, guys, what's true about the x-axis? What's the value of all the y's at the x-axis? 0, okay? So the x-intercept is the x value when y equals 0. So you might not be able to clearly see it from your equation that's given to you. But if you wanted to solve for your y-intercept, or sorry, the x-intercept, you'd have to make the y value 0, and then you can solve for x. So it's been a while since our last 2-step equation. But anytime you're isolating a variable, you always start with what's farther. Not here. You always start with what's farther, so would that be the 8 or the 2? And how do I cancel out the 8? Good, whatever you do on one side, you do on the other side of the equal sign. On the left side is -8, on the right is a -2x. Opposite of multiplying -2 would be 2. Whatever you do on one side. And that is how you can solve for the x-intercept, is make the y value 0. Or you could also solve for the y-intercept by making the x value 0. Okay, questions on that? So in these equations, we see an x and a y, even though they usually say x and y. You can recognize it as your input and output, hopefully. And that you can solve for if you know x-intercept is when y is 0, y-intercept is when x is 0. All right, we are on lesson 10 of unit 6. We will be done with the unit by next Friday. So the goal of today's lesson is to find out what quadratic expression in standard and factor forms can reveal. So we learned about those two different forms recently. We'll see them again. By the end of the lesson, you need to be able to explain the meaning of the intercepts on a graph of a quadratic function in terms of the situation it represents, and know how the numbers in factor form of a quadratic expression relate to the intercepts of a graph. I record every day, like I'm recording right now. I'll update this link. Puzzle piece is lesson 10. Reminder. So that coloring activity that you did yesterday, I wanted to make sure that I had down what you completed. Because if you lose it, you technically would have to start over. It's counting as a project grade in here. So there's only one other thing in the project category right now, that's your unit 5 binder check. So if you decided, I'm not gonna do this coloring activity, or I'm not gonna turn it in, or I'm gonna lose it, then that would be a 0, and that wouldn't be good in that 20% category. So please make sure that if you didn't finish it yesterday during class, when you turned it in, that you finish it and resubmit it, preferably through Schoology. However, next Friday, when I do the binder check, I can check it again. That's a lot of time in between. I don't want you to lose it from now and then. You can get some extra credit on it if you do the coloring part. But at a minimum, you need to be able to multiply all of the problems out. Okay, so that's the minimum requirement, is that you multiply all the problems out and show work. I'm pretty lenient on work shown, but like when you just have the final answer, I know you copied it from someone. You said it didn't work. All right, so I need to see what it looked like before you combine the ledger. But whatever method you want to use, fine. If you do your work on a separate paper, make sure you show me that scratch work, because that's half the grade right there. So work shown and accuracy, all you have to do is multiply all of them out. If you wanted to do that coloring part, that's the part where you added your answers together for each row or subtracted them in this part. And then you matched it to one of the colors. But that part is totally optional. If you didn't get it, I mean, it's in this bin back here along with a note sheet from yesterday that you need to save for your binder check. It's also uploaded to Schoology too. Do all the work on a separate piece of paper, because really that's the only part that's like the minimum requirement. Questions on that? Okay, just remind you of that. It'll go in as a project grade. I am gonna enter what you had when you turned it in, but not many people were done, so I'm kind of holding off, hoping that you'll resubmit it. And then I don't have to put in like the half credit grade for only having half of it done. I've been pushing this quiz all week. I'm pushing it to tomorrow. We will for sure have a quiz tomorrow over lessons 3 through 9. Make sure those notes are ready. Questions on that? Okay. Saturday Academy is Saturday. If you haven't had, you should expect an invite from me. I highly recommend everyone go though. It's a really great opportunity. So recently, maybe last week rather, we talked about projectile motion problems, and we saw that equations in this format can reveal certain things about the situation. So like, what does that 10 represent? Table 7, can you tell me what the 10 represents? It is the starting height. So if you see a projectile motion problem, so something being thrown, something being dropped, it follows that U shape. The constant, the single number, is my starting height. Table 8, are you able to tell me what that 78 in the problem represents? There is a way to tell just from looking at the equation, but the problem will usually tell you too. Velocity, so the number in front of the t will be the velocity if there is any. If you drop something, you're usually not having velocity involved. But of course, if you throw something versus dropping it, then it's gonna get there faster. So that's why that's there. Table 9, where does that negative 16t squared come from?
Sorry, I didn't get that. That be the speed of the visions?
I'm sorry, what?
Would that be the speed of that visions?
Yes, in a way, and that comes as a result from gravity. We know, or someone discovered, Galileo discovered, that when something falls on Earth, it drops at a factor of like 16 units per second. So that's where it's coming from. So yeah, good to review. Would you say, based on our lesson about standard versus factor form, class, would you say that that is in standard or factor form? It is considered standard form. Although some math teachers will say that it should be written in this order, where you have the higher exponent first and then like descending order. But this does closely resemble what we said standard form is. And that's ax squared plus bx plus c. So yes, it is standard form. For other reasons, how you know they're not written as factors, you can't multiply in there, it's already fully simplified. Now, Jada said that this equation, g of t, let me highlight it, also defines the same function written in factor form. How can I show that Jada is correct? I'll give you some time in your group to figure that out. How can I show that this is equivalent to the standard form? You will be asked that on your final. How do you know that these are equivalent? I'll give you about 2 minutes. If you finish early, start reading ahead to the next part. So we can prove that those two equations are equivalent. Okay, you could do the box method. So you could multiply out the factored form, get it to where it's fully simplified, and then see if it's the same. There is another way too. Does anyone know what that other way would be? How to tell if two equations are equivalent? FOIL also, other than algebra. Graphing, you can also do that too, which if you have access to a graphing calculator on your test, that's probably going to be the faster way. But you do still need to know how to multiply them out. So that's what I'll show you on the right side over here. All right, so how you do it, FOILing, box method is up to you. But in each situation, you are multiplying the same exact terms together. So if I choose to do FOILing, here's my first terms. Table 2, what's negative 16t times t? Okay, good. Table 3, my outer terms. These two, what do I get when I multiply them? Okay, I haven't done the math yet today, so I'm gonna choose to believe you that 16 times 5 is 80. But it definitely should be positive, so if anyone wants to check that part, feel free. Table 4, my inner terms. Negative 2 times t is what? Negative 2t. And table 5, my last terms multiplied together is a positive 10. Make sure you put a plus 10. I know we don't normally write the plus when it's positive, but in these situations, you have to, because you're having to separate the terms. To make it look exactly like our given expression, combine our two middle terms or our like terms. 80t plus negative 2t is 600. And now it looks like our given equation. So that's how you can prove their equivalent. You could show the work of you multiplying it. You could describe how it looks on a graph. All good stuff. All right, so now here's if you did graph it. It would look like just one line graph, even though they're given to you in two different forms. It says identify or approximate the vertical and horizontal intercepts. And what do each of these points mean in this situation? If you haven't gotten that far, I'll give you about a minute to review those answers with your groups. Identify our intercepts and what they would mean in this situation. So I can't remember where I left off on. I want to say it was table 7. Table 7, identify one of my vertical or horizontal intercepts and tell me what it would mean. So vertical intercept would be referring to what kind? Where does it look like it's touching on my vertical axis? Okay. It is 10 exactly. For our vertical intercept or y-intercept. It's probably more what you recognize it as. Class, what does that 10 represent? Good, it represents our starting height. We talked about that when we evaluated the equation, right? Because it was a constant in the equation. So in standard form for projectile motion problems, you can identify some things like that. Can you see the x-intercept in our standard form? Just think about that. Table 8, can you tell me what my horizontal or x-intercept is? My x-intercept is 5. At least that's the only one that makes sense. If I put it in Desmos, I'll see another one, but that one doesn't make sense. Our x and y values are restricted to just positive numbers. Now, can I see that in my standard form equation class? Do I see a 5? Do I see a 5 in my factored form equation?
Yeah.
So yeah, it's a -5. But what is that 5 representing in the real world situation? 5 what? What is our x-axis? It's time in seconds. So it represents 5 seconds, and what happened at 5 seconds? It hit the floor after 5 seconds. So it represents 5 seconds, or at 5 seconds, it hit the ground. It was in the air for 5 seconds. So you can't see it that well from your standard form, right? But you can see it from the factor form. That's gonna be something you're going to have to interpret. Our x-intercepts from factor form is gonna be the value of the t that makes it true. And So 5 is easy to figure out. What's another word for x-intercept that we've learned? It was like in the same lesson that we talked about vertex. Trying to remember myself. It's a vocabulary word. I told you that this word means x-intercept by definition. So zeros. Bring back memories. When it asks you to identify zeros, it's asking you to identify your x-intercept. So my 0 in this situation is 5. Not the y-intercept, that's not considered a 0. That will be important later. But for right now, you just need to know our x-intercept in this situation tells us when the item hits the ground, and it's at 5. And you can see it better in the factor form. You can see your y-intercept better in the standard. Questions on that? Okay. On the back, you have an activity which I really like. I think it's really helpful in understanding a certain pattern about these x and y intercepts. So we have a bunch of different graphs along with their standard and factored form expressions. Each pair gives you, or what you are going to do for each pair is identify your x and y intercept. You might notice a certain pattern, or if not, at least I'll draw your attention to it once you're done. But in each situation on the back side of your paper, you're going to identify your x and y intercept. Any questions on what you're doing? Since there are 6 graphs and there's about 2 to 4 of you in every group, I'll give you 4 minutes to identify those parts of each function. So table 1 for function f, what are my x-intercepts? All right, -1, I agree, that's where it touches on the x-axis, and -3. I'm gonna write them in coordinate form, just so that you guys can remember. X-intercept is when the y is 0. But technically you could have just said -3 and 1, and that would have been fine. Table 2, what is my y-intercept for this one? Okay, I heard 3 and -3. Y-intercept is when the x is 0. I agree it touches at 3. I don't think it touches at -3 though. So this one has just one y-intercept. Oh, okay. But yeah, just one y-intercept for this one. Any questions on how to find that? Good. Table 3, what about function g? What's my x-intercepts? 1 and 4. For my x-intercepts. I'm writing them in coordinate form. Maybe you pass at 1 and 4. Table 4, what about my y-intercepts for function g? 4. Okay, questions on that? Are we noticing any pattern so far with the equations? Okay, there's 2 x-intercepts. So far, just 1 y-intercept. Let's keep going, maybe we'll see more stuff later. Where am I? Table 5, what's my x-intercept for function h? -3 and 3 is correct. Table 6, what about my y-intercept for function h? 0, did you say 9?
Yes, -9.
-9, yes. Right here is where it touches. Table 7, what about for function I? What are my x-intercepts? 5 and 0 is correct. Table 8, what about my y-intercept for function I? Or does it touch on the y-axis for function I? Are we looking at the right one? Function I, y-intercept,
Oh. 0?
0. This one happens to have a y-intercept and an x-intercept that match because it goes through the origin. And then it touches nowhere else on the y-axis. So before I scroll down, there is a relationship between the x-intercepts and our factored form. So I'm gonna highlight our factored forms in blue. To kind of match what we noticed about or what we wrote down for our x-intercepts. I'll highlight the standard form in pink because that's the closest I have to red. There's also a relationship between the y-intercept and our standard form that you can see better. So kind of keep that in mind. We still have 2 more to talk about. Table 9. What are my x-intercepts for function j?
0, 5.
Okay, good. 0 and 5, I agree, that's where they touch. And table 1, what is my y-intercept for function j? 0. Table 2, what's my x-intercept for function k? Okay, I don't see that it touches here on the line. That's 0. It does touch at -2. Were you saying it as a coordinate? Okay. So then that'd be -2, 0. Just one x-intercept for that one. Or 1, 0 for that one. Table 3, what about my y-intercepts? Good. 0 for the x, 4 for the y. That's how we write our y-intercepts. Any questions on the identifying? I'm sure that in Desmos you could do that. I'm gonna tell you right now on your constructed response, you will have questions that say something about, here's a graph. What's the equation for that graph? So making you work backwards. If you could look at the relationships between the x-intercepts and the factor form, and maybe the relationship between the y-intercepts and the standard form. See, like, where are we seeing the 5 and the 0 in function j? Where are we seeing the 0 in the standard form of function j? And then you could do that for every single other graph. Okay, does anyone think that they know the pattern? So think about it. You don't have to say it out loud yet. But the blue and what I highlighted in blue for function f, our x-intercepts were -3 and -1. Where do we see them in this equation? The second number, although this one is positive and the other is negative. But you're right, there is a trend there, sorry, like glitching out. Okay. Let me go back. So it's like the second number, except for what? It has an opposite sign. Is that true for this one? Do we see our x-intercepts in the second number of our factor form? But again, it has an opposite sign. Down here, do we see our x-intercepts in our factor form? Now, look at your y-intercepts and our standard form. Where do we see our y-intercept in our standard form? For function f. Where do we see our y-intercept in function g? What happens when our y-intercept is 0? What do we notice about those equations? There's not that single number that's there. Right? So just some things to notice. You can jot down those observations if you like. But now if I give you just the factor form, I want you to predict without graphing what the x-intercepts would be and what the y-intercepts would be based on our conversations. Okay, do that. Look at your graphs. Annabelle, what do you think our x-intercept is going to be for number 2? 9 and 1 is correct. And that's without graphing, you can tell. So far, the trend we've noticed is that it happens to be like our second number, but with an opposite sign. And these do happen to be the x-intercepts, that's correct. To find my y-intercept, is it that easy right now? You could make it standard form. We saw that it was easy to identify when it's in standard form. What else could you do? You could remember that the definition for y-intercept is when what happens? We talked about it in our warm-up. When x is 0. So if this is equal to my output, and I make the x's 0, and there just happens to be 2 in them now, I can solve for y. What's 0 minus 9? Negative 9. What's 0 minus 1? And when I multiply them together, my y-intercept is going to be 9 without graphing. So if you got that your y-intercept is 9 without graphing, good job. Could have also made it standard form and saw that as well. So anyone confused? Anyone not know what we are observing as far as the pattern? All right. In this very last one, this is almost like a check for understanding your cool down. Here's 2 equivalent expressions without graphing, be able to identify the x and y intercepts. And then once you've done that, I'll put up the answer in a few minutes. But once you've done that, then you have some time to work on your practice for this lesson, 6.10. I'll put this answer up shortly. Okay, the answer for the cool down is on the screen. X-intercepts are -2 and 4. Y-intercept is 8. Questions on that? And that's without graphing. Of course, you could always graph and check your answer, but hopefully you're noticing the pattern. There's lots of great study materials out there. Like I just Googled zeros of a quadratic function. This can help you practice. Like, think about it. What are the zeros of this quadratic function? You can click it and it'll tell you. And then there's lots of practice examples. Just seeing if you're understanding the pattern. Highly recommend. Google's a great tool.